Our inconceivable lead is way out of this world 390 light-years away, truth be told, for setting 1 light-year is indistinguishable from 6 trillion miles. In humanity's determined mission for loosening up the mysteries of the universe, we've set off on a journey that goes beyond time itself, searching for answers to age-old requests woven into the surface of existence. The James Webb Space Telescope, with its unblinking eye, has as of late recognized a brief glance at a structure predating the presentation of stars. This magnificent thing appeared to be more ancient than the universe itself, raising more questions than it answers. How might a structure exist that begins before our universe, or is a hypothesis of how things became to blame? Join us as we set out on an odyssey directed by the discoveries of the James Webb Telescope, where the secrets of a 13.8 billion year old cosmos await. Furthermore, the journey to unravel these colossal mysteries has just barely begun. In a distant corner of the universe, around 200 light-years away, an old star called HD 14283 resides near the Libra constellation. This magnificent Voyager moves energetically through space, offering brief glimpses into its violent past. Precisely a few billion years ago, when our Milky Way was still in its infancy, it absorbed a dwarf galaxy that once called it home. But what truly piques our cosmic interest in HD 1414283 isn't just its fast cycle, it's its astounding age among the celestial entities we've noted. It remains one of the oldest, earning the enchanting moniker Methuselah Star compared to the biblical figure Methuselah, who legend has it lived for 969 years, initially estimated to be a dazzling 16 billion years old. The latest estimates suggest a somewhat younger period of 14.46 billion years, with a margin of error of 0.8 billion years. This reation about its age confounded astronomers. After all, the age of the universe, calculated from the cosmic microwave background, hovers around 13.8 billion years. This issue raised major questions about the star's age, the universe's age, and even the accuracy of our dating methods. Let's break it down. Figuring out the age of great objects can be a genuine challenge. Take stars, for instance, like the sun. They're akin to timeless lights, maintain their radiance, temperature, and size for billions of years, making them intriguing to age. Space scientists use changes in brilliance and color as clues, combining these with models predicting how stars evolve over time. One age giveaway is how quickly a star spins like a wheel, slowing down over time. Stars do this too. By comparing the rotational speeds of stars at different ages, astronomers have figured out a clever trick called gyrochronology. Stars also spill their age secrets through magnetic chatter, flares, and emissions of energy on a star's surface, resembling the star's fiery energy. Astronomers, being the space investigators, they use advanced techniques like astroseismology. It's like eavesdropping on a star's internal conversations, focusing on vibrations caused by waves traveling through its interior. These vibrations reveal the star's age. For instance, applying this cosmic snooping, space scientists aged the sun at 4.58 billion years. Now back to Methuselah Star, the old radiation around. It isn't just inconsistent space. Scientists tagged it with an ancient age by checking its cosmic metal content. Stars can be classified into groups based on how much bling or heavy elements like iron they have. Our sun is somewhat of a metal head belonging to population 1 stars. Methuselah Star, on the other hand, resembles an ancient relic from population 2, rocking fewer heavy elements. It's the cosmic fingerprint that helps astronomers play galactic archaeologists, unraveling the age stories of these celestial bodies. Now Imagine a gathering of stars population, 3 which analysts believe might be the universe's most extraordinary gems while they're still hiding in the background and haven't yet appeared in our telescope spotlight stargazers suspect. These stars might be the legends of creation containing almost no heavy elements to understand the grand plan. We need to rewind to the universe's early days after the Big Bang picture an endless kitchen filled mostly with hydrogen and helium, the universe's essential ingredients, about 92% hydrogen and 8% helium, or if we estimate them, around 75% hydrogen and 25% helium. In this vast ensemble, the first performers were the population 3 stars. They were enormous and hot, burning their fuel rapidly, changing hydrogen and helium into heavier elements. When these early cosmic giants exploded, they spread these heavy elements into the vast territory in line with the population 2 stars forming a bit later. Yet in the universe's early days, their original materials were loaded with heavy elements, especially iron. Many of them went through their celestial life cycles, exploding into supernova, adding more heavy elements to the universal mix. Eventually, the population 1 stars, including our Sun, emerged as cosmic mavericks, forming from advanced gas clouds mixing with remnants from the earlier population 2 stars. Now the central question: does the grand story throw a cosmic curveball at the theory of the ancient cosmic explosion? It's a head-scratcher, but here's the twist. There's a 70% chance that Methuselah Star, the old cosmic vagabond, could be in the vicinity. There's a 13.66% chance that this ancient celestial wanderer's age is playing outside the cosmic rule book. Similarly, there's a 15% chance it's not quite as old, but much younger. Imagine rolling a standard 6-sided die and expecting one of 6 statistically possible outcomes regardless of what these cosmic curves throw at us. What's certain is that Methuselah Star isn't just a colossal veteran, it's the granddaddy of stars. We've managed to give it an age label that's incredibly precise. Now, here's where it gets interesting. Instead of scratching our head about where Methuselah Star could be 2 or 3 billion years older than its cosmic neighbors, let's flip the cosmic script. What if the universe itself isn't as young as we once thought? Consider trying to understand the vastness of space itself. If we turn the entire history of the universe into a cosmic calendar with the Big Bang as the most monumental new year's fireworks, Earth wouldn't join the cosmic party until the final seconds of December 31st. Human written history, that's only a blip in time, covering just the last 10 seconds. Our cosmic agents determine the universe's age by looking at old starlight born a few hundred million years after the Big Bang. As the universe expands, it gives this light a vast makeover known as redshift. By doing the math on both distance and expansion, scientists declared a general time of 13.8 billion years. But hold on, because the cosmic situation starts to get fascinating. A limitless musing from the University of Ottawa suggests the universe might be a whopping 26.7 billion years old. Professor Rinder Gupta presents an intriguing theory from 1929 made by Swiss astronomer Fritz Zwicky, and it's stirring up our cosmic thinking. This theory complicates matters, proposing that as light particles, photons traverse the infinity of space, over time they lose some of their energy. Though this idea doesn't perfectly align with what we've seen through our telescopes, Gupta proposes a cosmic trade-off. He suggests we can blend this theory with our current understanding of an expanding universe, creating a hybrid explanation for the redshift phenomenon. Now fasten your seat belts. Changing the universe's age to an astounding 26.7 billion years is no small feat. Gupta adds another twist to the cosmic mix by combining the photon light theory with evolving coupling constants, a brainchild of theoretical physicist Paul Dirac. This idea proposes that how particles interact may have changed over time, and hey, scientists have a history of tweaking the cosmic clock. In the 1920s, Edwin Hubble thought the universe was just a simple 2 billion years old. We've come a long way since then, refining our cosmic math, multiplying the universe's age is like taking a giant leap in our cosmic vision, but we should pause for a moment. Whether this new perspective becomes the galactic norm is still up in the stars, regardless of whether humanity's written history is a mere blip of 10 or 5 seconds in the grand scheme of the universe. One thing is clear: the universe is a treasure trove of ancient wonders and endless inspiration. Looking to our astronomical backyard, the Milky Way, there's a stunning cosmic tango at play. Recent estimates hint that stars on the edges of our galaxy are strutting their stuff in slow motion compared to their partners in other galaxies. What's the cosmic scoop? Well, there are several theories, and one musing is that our Milky Way might be running nearly out of an invisible system ingredient called dark matter. This mysterious substance affects the gravitational dance of magnificent objects. There's an infinite riddle involving dark matter, the elusive substance we can't see but seems to play a gravitational back and forth in the universe. One possibility shaking our grand understanding is that perhaps we've been measuring dark matter wrong. Our universal compass might point off course. Here's where the European Space Agency's Gaia satellite steps into the cosmic spotlight. It's like our cosmic expert offering intricate insights into the dance of nearly 2 billion stars in our Milky Way. Think of it as a massive development test. The satellite's exact measurements have led astronomers to reconsider their grand cosmic notes. Stars at the outer edges of our Milky Way seem to be moving slowly, testing our old assumptions about their speeds. How do star speeds spill the cosmic beams about a universe's mess? It's like gauging the size of a gathering by how fast people are moving. Armed with Gaia's data, space scientists estimated the combined mass of our galaxy's gas, dust, stars, and that elusive dark matter to be around 200 billion times the mass of our Sun. It sounds like a galactic heavyweight, but here's the twist: it's several times less than we previously thought. One theory to settle this grand issue suggests we may have been a bit too heavy-handed with our dark matter estimates. Perhaps there's less dark matter out there than we once suspected. However, hold tight. Measuring the universe is like trying the impossible. The data could have some quirks, or our cosmic measuring tape might need some adjustments. Still, other research groups have joined the cosmic investigation, and they all seem to be murmuring the same universal tune that this grand discovery holds. It's like opening a new chapter in our grand physics textbook, a shift that might make us rethink not just our Milky Way, but every glittering corner of the universe. As Stacy McCardle, a space expert at Case Western Reserve University, puts it, this could be a cosmic game changer, returning to the cosmic journey of the 1970s when astronomer Vera Rubin and her immense team embarked on a celestial mission. Their goal was to study how stars moved in different galaxies. The Big Playbook suggested that stars on the edges of a galaxy should be cosmic doodlers compared to the zippy stars closer to the center. It's like how Neptune takes its time orbiting the sun, while Mercury is the cosmic speedster. Here's where the unexpected developments occurred. Rubin and her stargazing team uncovered a galactic surprise. Stars at the far edges of galaxies were strutting their stuff at almost the same speed as the ones closer to the cosmic dance floor. Imagine a vast disco where everybody, regardless of where they are, is moving to the same beat. This cosmic Revelation suggested the existence of something complex and secret dark matter, the invisible heavyweight champion that forms huge halos around galaxies. Consider early space scientists like Copernicus and Kepler. We've learned a lot since then, but we're still the learners, wide-eyed at galactic wonders, trying to solve the universe's mysteries. Our Earth is like a tiny island in the vast expanse of space orbiting the sun, surrounded by endless stars in our little galaxy. Our quest for significance among the stars is the heart of scientific investigation. Even when answers surprise us, this curiosity keeps us traveling further into the universe. It's an endless journey where every answer brings new questions, ensuring our grand exploration never stops. The universe continues to astonish us with its vastness and complexity. Each discovery leads us deeper into the intricate tapestry of galactic history, revealing the fundamental rules that govern our reality.